Hello, St. John's fifth grade students of the year 2020 to 2021. This is your second installment of summer preparation for fifth grade. Our first installment had to do with reviewing the multiplication facts. We continue with multiplication, and I am presenting to you right off the bat here one of the most important truths of mathematics going forward. I can't tell you how many times you're going to use this over and over again from fifth grade right on through probably the rest of the time you study math. The distributive property actually involves two operations. It involves multiplication as well as addition. We can say that for all numbers A, B, and C, if we have to multiply A by B plus C, the sum B plus C is being multiplied by the A. Notice the A is right next to the parentheses. I talked about that last time. This is a multiplication, the A times the parentheses. The distributive property tells us that that A has to be distributed to both the B and the C as a multiplication. Sometimes I like to draw little arrows like this. And the plus sign stays in between those two products. A times B, which is AB, plus A times C. That's the distributive property. Notice the key is that the A is being multiplied by the B and the C. Whether you know it or not, this is behind multiplication that you've already done. This is not just for middle school math. You already know the distributive property. And we'll see how it relates to the standard multiplication algorithm that you all know. A few more words about the distributive property. It also applies to subtraction. A times B minus C is A times B minus A times C. So that minus sign comes over here. And once again, we have to multiply A times B and the A times C. The distributive property also can apply to more than B plus C. There could be a B plus C plus D inside. And that's also something that you're familiar with because you've already multiplied a one-digit number by a three-digit number. We'll take a look at that. But if you have A times B plus C plus D, you just extend what you've already learned about the distributive property, and you realize that this has to be A times B plus A times C plus A times D. You distribute the A as a multiplication to each of the numbers that are being added inside. One last thing. We know that multiplication is commutative, so we can also write the distributive property like this. We could have the B plus C on the left and then the A over here. We're still going to distribute this A to the B and the C like that. Let's take a look at a multiplication that you all know how to do. Let's talk about, say, 8 times 26. How about that? 8 times 26. Here's what you already know. 8 times 6 is 48. Put down the 8. Carry the 4. 8 times 2 is 16. Plus the 4 is 20. And the answer is 208. This, by the way, is known as the standard multiplication algorithm. An algorithm comes from Arabic words, actually. The Muslim Arab culture around the year 1000 AD was very learned and responsible for taking some of the ancient math, developing it more, and providing it for future generations like us. The word algebra also comes from Arabic. Algorithm sounds mysterious and complicated, but it's simply a series of steps that are taken to answer a question, a series of math steps that are taken to answer a question. This is the multiplication algorithm. Well, what about the distributive property? 26, of course, can be thought of as 20 plus 6. So notice from before, this is the A. The 8 is in the position of the A. This is the B, and this is the C. So how do we multiply here using the distributive property? 8 times 20. That raised dot there, by the way, that's not a decimal point. It's a raised dot. It means multiplication. I could have put an X there, but this raised dot is sometimes used in middle school math. I'll introduce you to it. So we do 8 times 20 and then plus 8 times 6. 8 times 20 is 160, plus 8 times 6 is 48. And guess what 160 plus 48 is? 208. So what I like to say is, this is what's really going on. The distributive property is what's really going on in the standard algorithm. We could have redone this standard algorithm. You know, we're taught to put down the 8 and carry the 4, but how about if we do 8 times 6 is 48? And now when we do 8 times 2, that's really not a 2, is it? It's a 20. So now we have to do 8 times 20, which is 160. And then we add them together. And of course, this is identical to what's over here, except it's vertical instead of horizontal. Now the standard multiplication algorithm just conserves ink and conserves time. Rather than write out all those digits, you know, by putting down the 8 and carrying the 4, we're going to, the 8 being here forces us to really, when we're doing 8 times 2 here, we're really doing 8 times 20 because we're going to put it next to the 8, so it's forced over a place, and it's not 16, it's 160. But then we're going to add the 4 that we carried to get that 200, right? 208, 16 plus 4. Okay? So the distributive property, anytime you go beyond 9 times 9 or 9 times 10, you're really using the distributive property whether you know it or not. Let's look at multiplying a 1-digit number by a 3-digit number. How about 8? I'll use an X here. 8 times. Oh, how about 497? 8 times 497. Now, ladies and gentlemen, here's a skill that's part of middle school math. I think it's important. I would like you to realize that the answer to this multiplication is a little less than 4,000. How do I arrive at that? Let's keep the 8 the same. It's a small number, so we don't want to change it to 10. We don't really need to do that. I intentionally chose a number here that's close to 500. So how about if we think of this as 8 times 500? And that is, of course, 4,000. 8 times 5 is 40, and there's the 40, and then 2 more zeros, right? That can be done mentally very easily. Now this has to be less than 4,000, but we expect it to be somewhat close, okay? We can use the distributive property 2 different ways here. We can use it using addition and also subtraction. That might be kind of cool. Let's do that. 8 times 400 plus 90 plus 7. The number was 497. That's 400 plus 90 plus 7. Oh. Remember, we can just put the 8 right next to the parentheses. That means multiplication, right? 8 times 400, 3,200. Plus 8 times 90, 720. Plus 8 times 7, 56. Now, if you need to line those up vertically and add them, go ahead, but I think it's 3,976. I'm just kind of mentally lining them up. 3,976. Notice a little less than 4,000, as we predicted. In fact, I knew that it was going to be 24 less than. This is 24 less than 4,000. We'll look at that in a minute. But let's first look at the standard multiplication algorithm. 497 times 8. 8 times 7 is 56. Put down the 6. Carry the 5. 8 times 9 is 72. Plus 5 is 77. Put down the 7. Carry the 7. 8 times 4 is 32. Plus 7 is 39. There we go. But what we really did here was, just like before, we really multiplied 8 times 7, 8 times 90, and 8 times 400. And the standard algorithm abbreviates things. We don't have to write everything out the way we did here. But this is really what's going on behind the scenes here. That's the important lesson. I said we would look at this with subtraction. And I said that I knew that this was going to be 24 less than 4,000. Do you recognize that? If you add 24 to 3,976, you'll get 4,000. Let's see why that's true. The distributive property can help us. We're doing 8 times 497. Well, I thought of 497 last time as 400 plus 90 plus 7, but it's very close to 500. So how about if we write it like this? $497 is 500 minus 3. 8 times 500 is a 40 with 2 zeros after it. It's 4,000. The minus sign comes down. 8 times 3 is 24. We distribute the 8 to each of the numbers inside, separated by that same minus sign. This is why I said earlier, you see, a common mistake is people might look at this and say, oh, 8 times 5,000 is 400. I'm sorry, 4,000. And this is 3 less, so maybe the answer is 3,997. Just subtract 3 from the estimate of 4,000, but you actually have to subtract 3 times 8. This 8 is in the distributive property. This 8 is being multiplied by the 3, and so we subtract 24 from the 4,000 to get the same answer we did last time, 3,976. So the distributive property works with subtraction as well. You might have noticed that so far we've multiplied a single digit number by some other number. Well, sometimes in life we need to multiply by bigger numbers. So let's move on and look at 2 digits times 2 digits. The first thing I'd like you to do is come up with an estimate for 39 times 61. This is an easy one to estimate with. It's difficult to estimate with whole numbers that end in 5, like if you had to do 35 times, or numbers that are near 5. If you had to do 35 times 76, it's hard to come up with a really close estimate, because when you round to the nearest 10, you know, you're rounding a lot. When you round, what was it, 35 up to 40. But this is very close to 40. This is very close to 60. What's 40 times 60? You should know that. You should be able to do that mentally. 2,400. 40 times 60 is 2,400. So we can say that I'm so happy because I just realized I could introduce another symbol to you. You see that squiggly equal sign there? You know what people in math call that symbol? A squiggly equal sign. At least that's what I call it. I've never heard it called anything else other than about equal to. That's what it means. The squiggly equal sign means about equal to. So 39 times 61 is about equal to 2,400. Let's do the standard multiplication algorithm. 61 times 39. 9 times 1 is 9. Nothing to carry. 9 times 6 is 54. Now what do we do next? Before moving on to the 3. You know, we have to put a 0 here. Why do we put a 0 here? Because this is not really a 3, this is really a 30. By putting a 0 here, we'll be pushing everything over by one place value to recognize that this is really 30. 3 times 1 is 3. 3 times 6 is 18. These here are called the partial products. When you're multiplying, the answer you get to a multiplication is called product. The product of 2 and 3 is 6. Well, this 549 is the product of 6 and 91. This 1830 is the product of 30 and 61, but they're only partial products to the overall problem, so they have to be added together. 3 carry the 1 here, 2,379. Now, does that pass the reasonableness test? By the way, you're working out a math problem, you think you're done, ask yourself if it's reasonable. Does it make sense? If it doesn't, you could probably fix it. 2,379 is close to 2,400. It's a reasonable answer. I could be confident in it for that reason. But how does the distributive property work here? Because the distributive property is really at work in this problem, behind the scenes. 30 plus 9 times 60 plus 1. Here's another example, and I wish I had an 8th grade, graduating 8th grader with me who just went through a high school Algebra 1 course, and that student would say, I would ask that student, do you ever have two numbers added together in parentheses times another parentheses with two numbers added together? And the 8th grader would say, oh yeah, we do that all the time. It's true, they do. The parentheses are right next to each other, so it's multiplication. I'm going to think of this as the A out here. This whole parentheses is the A, and this is the B and the C. I'm going to distribute this to the 30 and to the 9. Now you might wonder why I don't distribute this to the 60 plus 1. Remember I showed you earlier that the distributive property could look that way. The A could be over here, or it could be over here. Well, this is the A, and the reason for that is it's sort of an agreed upon way to do things in algebra. So I'm kind of going along with the way we do it in high school algebra. So here's what I'm going to do. 30 times 60 plus 1 in parentheses. Now this plus sign comes down here, and I multiply, again, distribute the 60 plus 1 to the 9. So I do 9 times 60 plus 1. That 60 plus 1 is a number. It's in that parentheses, so we think of it as one number, even though it's 60 plus 1. In fact, it's 61, right? So I'm distributed the 60 plus 1 to the 30 and the 60 plus 1 to the 9, separated by the plus sign. Now we have the distributive property two more times. I sometimes call, when you're multiplying two-digit number by two-digit number, I call it the super distributive property, because the distributive property really appears 3 times. We've just done 1, and now here are 2 more. 30 times 60 plus 30 times 1, right? And we can do these mentally. 30 times 60 is 1,800 plus 30 times 1, which is 30. Now that plus sign. 9 times 60, 540, plus this plus sign here. 9 times 1 is 9. Okay? Now, I'm going to take a little shortcut here in terms of adding those 4 numbers together. Those 4 numbers added together will be 39 times 61. But rather than add 4 of them together, let's look back over here at the standard multiplication algorithm. You see that 1800 plus 30? Do you see that anywhere else on the board? It's right there. That 1830 that we got through the standard multiplication algorithm is right there. 1800 plus 30. And the 549 that we got here, there it is. Same answer. A lot of you are probably wondering right now, do I have to do this? Well, I might ask you to, for practice, to learn the distributive property. I might ask you to go through this. Will you be doing that all the time? No, you're going to use the standard multiplication algorithm. Why? Because it's a shortcut. It's efficient. But just like before, over here, the distributive property is really what's going on behind the scenes when we use this nice multiplication algorithm. Here's something cool. I could say that every day, every minute before I introduce something new, every couple of minutes. Here's something cool. Why? It's math. Oh, you had to ask. Multiplication is commutative. Before I had the 61 on the top, the 39 on the bottom. I could have reversed those two up there too, but I'm reversing them here, and I reversed those two parentheses from before as well. Now we should get the same answer. Right? Multiplication is commutative. Let's go through the standard algorithm. Well, 1 times 39 is 39. This is really a 60, so we put a 0 there. 6 times 9 is 54. Put down the 4, carry the 5. 6 times 3 is 18, plus 5 is 23. Adding the partial products. There's the same answer, 2,379. And if it weren't the same answer, there would have been something wrong, right? Because multiplication is commutative. Well, just like before, we're going to take that second parentheses because it follows a tradition that we get to in Algebra 1. Take that second parentheses and distribute it. This is like the A. This is the B, this is the C, this is the A. So we're going to distribute that 30 plus 9 to the 60. And then this plus sign comes down, and we distribute the 30 plus 9 to the 1. So 1 times 30 plus 9, like that. So now we have the distributive property 2 more times. 60 times 30 is 1,800. 60 times 9, 540, with that plus sign in between. And then plus 1 times 30 is 30, plus 1 times 9 is 9. So once again, do we have to add those 4 numbers together? We do not. They're right over here. Look at that 39. Well, there it is. There's the 39. And then these two here, 1,800 plus 540. You should be able to do that mentally. 1,800 plus 540 is 2,340. So once again, when we did the multiplication algorithm, this is really what was going on over here. The distributive property. It's awesome. Another look at 39 times 61 and 61 times 39. The multiplication of whole numbers can be thought of as repeated addition, or a shortcut for repeated addition. 39 times 61 means 61 plus 61 plus 61 plus 39 times. I'm not going to write them all out. You would have to add up 39 61s. Imagine how much writing you do there. That's why we have multiplication. And 61 times 39 would be 39 plus 39 plus 39, 61 times. I hope I said it right the other time. 39 times 61 is 39 61s added together, and 61 times 39 is 61 39s added together. I'm not sure if I said it right the last time. you know, if we think about it vertically, like this, take the first one. I'll just do it with the first one. Let's imagine we wrote out 39 61s and then we're going to add them together. Well, this is kind of easy here because adding up 39 ones would give us 39. And then we would have to add up 39 60s. 39 60s. Well, you know, you can see the distributive property at work there. I think it's yeah. Rather than thinking of the 39 as 30 plus 9, let's just think of it as 39. Okay? The 61 is 60 plus 1, and we have to multiply that by 39. Well, what are we going to do? We're going to multiply 39 times 60, and if you were adding up 39 60s, that's 39 times 60. And then you'd have adding up the 39 ones, of course, is 39. That's the 39 times 1. So the distributive property, you could see that it's at work here. Even if we were adding, you can easily see how the distributive property applies to this multiplication, which is repeated addition. Now, a word of caution: when we get to the multiplication of fractions, we're going to have to come up with a different understanding of the multiplication. Because let me just give you a little flavor of that now. 2/3 times 5/7. I'm tempted to tell you what the answer is because this is the easiest thing that we do in middle school math. And maybe some of you know, perhaps, not likely. If any parents are watching along with the students here, you know how tempted I am to just say that it's, no, I'm not gonna tell you, but it's really easy. The point here is that even though it's extremely easy to come up with the answer to this, it's hard to explain why it's the answer. That'll take several classes down the road, a few months into 5th grade. I'm not sure exactly when, but it won't be right away. See, we cannot think of this as repeated addition. What do we add? How many 5/7 are we adding together here? We're going to add 2/3 of a 5/7. It doesn't work. So we have to have a different understanding of multiplication when we're dealing with fractions. And by the way, you might wonder, what about decimals? Well, decimals are fractions. This is going to be one of our key lessons in 5th grade, is that what we think of as decimal numbers are really fractions. So we're going to, whatever we learn to do with fractions, we'll be able to do with decimals. Just a little bit of a hint of what's coming later on. So I'm actually recording this video on June 16, the same day that I recorded the first installment. And at this point, I'm not sure what I'm going to provide you for work to go along with this video. I see that it's over 28 minutes now. I don't want these videos to be super long, so I'm gonna call this one quits soon. Certainly, I will provide you with some whole number multiplications to practice, and according to the standard algorithm. And I might ask you, like I indicated before, I might ask you to use the distributive property just to get used to how that works. Maybe do both on the same problem like I did and compare and see how you get the same answer using the standard algorithm and then the distributive property. And whatever papers I provide for you, I'll give some instruction there, some guidance as to how to do it. And there won't be many of them. Just a little bit. This, you should know how to do this already. Just a little bit for practice and reinforcement. And I hope that you paid close attention to everything I said about the distributive property, because it's not just with the multiplication of whole numbers. We do it in pre-algebra and in algebra and all through high school. The distributive property is extremely powerful. You actually use the distributive property, believe it or not, just to give you an example of how powerful it is. One of the key big things, if you parents, or if you fifth graders ask your parents, what are some of the things you remember about fifth grade math? Well, if your parent doesn't come up with it right away, ask your parent, well, what's a negative times a negative? And your parent may remember that a negative times a negative is positive. Now that's weird. Why is that? Going back to something I've mentioned to you before about the why. My job is the why. I'm going to explain to you why a negative times a negative is a positive. The only way to do that is with the distributive property, believe it or not. It's very powerful. That's just one example of how it's used. Like with the multiplication facts, which you internalize, you get into your long-term memories. The distributive property will get into your long-term memories, and you will, when you encounter it, you will do it automatically in the future. By the time, certainly in 7th grade, the 7th graders are using the distributive property all the time, and even without really thinking much about it, it becomes very natural. So appreciate its power. Take my word for it now, to some degree. You have to do that, but believe me, it'll come up in the future. So that's it for now. There'll be some written work to accompany this video, but that's the end of the second installment. There'll be one more for us before we get back together for the 5th grade school year. It's been nice chatting with you. Bye-bye.